Okay, this is for Precalc, and we are reviewing for a communications test, which is going to cover some pretty in-depth log material. So here is a little review for your communications test coming up tomorrow. I'm not going to do a full review. If you want a full review, our review worksheet is very thorough and has all the answers posted for it, so that should help a lot. Here are some things we started with. At the beginning of the year, I started with this, and I said, why can't I solve for x? There's no way to get the x off of there. We could graph both sides and see where they cross, but other than that, we don't have an algebra way to do this, so that's what introduced the need for logs. So to be a log problem, this needs to be rewritten as log base 5 of 8 is equal to x. There, I have rewritten this as a log problem. Now, could I put this in a calculator? Absolutely, if you know how to do it. This is a base 5 right now. So, of course, to rewrite this in the common log, also known as base 10, I need to rewrite it like this. Log 8 over log 5. Right, that is base 10. Well, wait, you say, there's no base. But if you don't have a base, that implies your base is base 10. So this was base 5 because it has a base. This one is base 10 on the top and bottom. So that is how you rewrite this as a log, and then in terms of base 10. All right. Another topic that came up a lot was ln, log base e. So if you saw ln of, let's say, 5, I hope you know that means log base e of 5. Now, if you wanted that to be in base 10, it can be done. You just have to rewrite this as log 5 over log e. But wait, you say, that's base 10, even though it has an e in it? Yeah, because the base is base 10 on both of these logs. It's just that it has an e in the argument. That's okay. E is just a number. It's about 2.718. It's on a graphic calculator right above the divide key, and it's a repeating decimal, or not repeating, sorry, it's a decimal that goes on forever, infinite decimal. So we round it usually to about 2.7. So that is how you handle ln's. You rewrite them as log base e. Now, let's say that I had a log base 5 of 25. I hope by now you know that you're supposed to set that equal to x, and then you could rewrite it as 5 to the x is equal to 25. Notice I just made it into an exponential kind of problem. And 5 to the what power is 25? 5 to the second. X must equal 2. Now there's another way to solve that, and that's if you use this pattern. If I could rewrite this 25 as 5 squared, if this number and this number are the same, then the answer is the exponent. All right, so I could use that same thing to do like log base 7 of 1 over the cube root of 49, because I could say, I could rewrite that as a 7 to a power, and then I'll have log base 7 of 7 to a power, and what power would it be? That would be the power of negative, because it's 1 over, and this is a fraction, and the roots go on the bottom. That's the root. It's the third root, so I put the roots on the bottom. And then the 7 would need to get squared to turn into a 49, so that's a 2. So then the answer for this one is negative 2/3, because I've made it so that this base and the base of the argument are the same. So the answer is the exponent, negative 2/3. Could you have written that as equals x? Sure, and then you could rewrite it. 7 to the x is equal to 7 to the negative 2/3. And that makes it abundantly clear that since the bases are the same, x must equal negative 2/3. All right. How about expanding and condensing? That's another big topic. Let's say we had like log base 5 of x squared y over m. And I wanted to split that up, expand it as much as possible. Well, I'd say log base 5 of, let's see here. I got to split this up, and this part right here is x squared plus log base 5 of y. Okay, so imagine for a moment that I didn't even have the divided by m in the problem. If it was just this and I wanted to split it up, expand it, I would expand it like that. Now the rest of this problem is divided by m, and I'm going to then say minus log base 5 of m. Because with this divide, if you change that, expand it, it'll become a subtract sign. So multiplies become adds, and divides become subtracts. All right, now why wouldn't this be the right answer? Because you are supposed to expand it as far as possible. And what you should do at the end is look back at your arguments and see if any of these can be split up further. Y and the m can't be split up further, but that x squared can be. Of course, x squared means x times x. Now, could I write x times x? Sure. And then I could split that up into log base 5x plus log base 5x. Or even smarter, I could just say this exponent, the little 2, can go down in front. It's called the power rule. All right? So, there we have it. Now, is this expanded all the way? Yes, because all of my arguments are simple prime, either variables or numbers. You can't split them up further. Now, how do you tell if you could simplify it more? You look at your base, like this is base 5, and if this number was a 5, for instance, I could simplify this further. Or if this was a 5, or if this was a 5, or some like derivative of 5, like, really math derivative, but like something that has a 5 in it, like 5 squared or 5 to the third. If the bases were to match, I could simplify it further. Like, for instance, let's say I had log 1,000 x to the third. Well, then log, which means base 10, means log base 10 of 1,000. And then this times there becomes plus log base 10. I could just say log, and it would mean base 10. X to the third. Now, if I'm expanding all the way and simplifying all the way, there's still two things wrong. This part right here is an argument that hasn't been broken up all the way. So I take the 3, put it down front. And then this part right here can be simplified. You have to simplify it all the way. All right. I'm not going to just finish that one. I'll let you think about how you could simplify that further. Next topic. What if it is expanded and we need to condense it down? So let's say it was log base 3 of m plus log base 3 of y. So if I want to condense this, I look at this plus and I say, okay, I can rewrite this as a time. This argument and this argument can be multiplied together. M times y. And then there's only one log. Notice the directions will always say, make this a single log. And if you write the word log twice, you are doing it wrong. This is log base 3 of my. It's nice to put your argument in parentheses. It's not required, but it's nice. It makes it simpler for you to understand. If you did put minus 7 here, that means you move the whole thing down 7 on a graph. Okay, so that was a simple condensed problem. Now let's make a complex one. Let's say it was 5. Log base 2 of y plus 3 log base 2 of m, and then all minus log base 2 of, let's say, q. Okay, first thought on this one. This 5 can be distributed to both of these. And that would become 5 here, and 5 times 3 makes it 15 there. There, I've distributed to 5. Now, those 5s can go up to the exponent spot right here. And this 15 can go to this exponent spot right here. So now it's not here, and it's not here anymore. Now I have log base 2 of y to the 5th plus log base 2 of m to the 15th. Now I'm going to subtract log base 2 of q. All right, so I did a little bit of condensing there. I basically just fixed the exponents. Now I'm going to put this plus part together. that's going to become log base 2 of y to the 5th times m to the 15th. Now I still have this minus log base 2 of q to deal with. Q got funny there. Let's try again. So now the subtract tells me I should make a divide. And again, your answer has got to be a single log. So it's just log base 2. And I got to put this all together, this part and this part. And it becomes a divide. Y to the 5th, m to the 15th, all over q. There we go. I've got it down to a single log. And then you ask yourself, is there any simplifying I could do in here? Like if there was a y on the end of this, like qy, if there was a y down here, I'd be able to cancel and say, oh, y to the 5th becomes y to the 4th, and this y cancels. Don't forget to go back through and make sure you have simplified all the way. And I added that y in at the end there just to say what if. But look and see if the argument is simplified all the way. And if you're condensing, this would be the right answer. If you were expanding, you'd make sure that your answer kind of looked like this black one we started with, where you'd have to make sure that your exponents have been expanded all the way out. So again, the original problem looked like this. This would have been a great answer for an expand problem, because this one is expanded all the way. Because I look at my arguments and I say, oh, that can't be expanded anymore, that can't be expanded anymore, that can't be expanded anymore. And if this doesn't match this in any way, see the 2 doesn't match an m and 2 doesn't match a q, then I probably don't need to do any more simplifying. Again, you wouldn't want to leave something like 2 log base 2 of 2, because this part's equal to 1, and 2 times 1 would be 2. So if you can simplify by making these guys the same, you do want to simplify that down. So watch for that. All right, that's all the advice I have for you on our final day of review for this communications logs test. Have a great day.